Hello everyone, hope you all are well. Today we will discuss a new topic in thermodynamics, that is thermochemistry. Basically, it is also a branch of chemistry which deals with heat change in a reaction. Suppose if any reaction is taken place, during that reaction heat is evolved or it is absorbed. This heat change is studied in the branch that is thermochemistry. Suppose, for example, if we consider this reaction, C plus O2, it will form carbon dioxide along with the evolution of some amount of heat. This is some amount of heat which is evolved during the reaction, means which is released out during the reaction. During this reaction, this amount of heat is released. This means there is the change of enthalpy. There is a change in heat. So, the branch of chemistry which deals with heat change in a reaction. So, in a reaction, this is the heat change. So, in that branch where we study about the heat change, that branch is called thermochemistry. Now, in this branch, we will study certain different types of enthalpy change or certain different types of reactions. First, we begin with exothermic and endothermic reaction. Exothermic reactions, exo means bahar, thermic means heat. From the word it is clear. Exo means outside ya bahar, thermic means heat. So that process in which heat is released. So whenever this process takes place, C plus O2, it will form CO2. There is the evolution of heat. Whenever we have written heat this side, in the product side with a plus sign, this means heat is evolved. Heat is released out along with the formation of product. So this is exothermic reaction. Next is endothermic reaction. Endo means inside and again thermic means heat. Whenever heat is absorbed or given to the system, heat is absorbed during the reaction, then it is called endothermic. Now see, in this reaction, hydrogen reacts with iodine and it will form hydrogen iodide. Then in this case, I have written negative sign here. This means this amount of heat is used during the reaction. So this amount of heat is given in the reactant side. Means this amount of heat is given during the reaction, absorbed during the reaction, and it is used in the reaction. That's why I put negative sign here. So always remember, exo means bahar, heat is released during the reaction. Endo means inside, heat is absorbed in the reaction. There is one more point to explain exothermic. If we write any equation like this, A plus B will react to form C plus D along with Q. If we write this type of reaction, and in another case we write A plus B plus Q, it will form C plus D. In this reaction, what I have did, two reactants combine to form products along with the release of certain amount of heat, because we have written it in the product side. So this heat is released, and in this reaction I have written this heat in reactant side. So this means this heat is absorbed. So this is an endothermic reaction and this is exothermic reaction. Now we consider next point, enthalpy change. Change in enthalpy means enthalpy of product minus enthalpy of reactant. Now understand this concept clearly. Here we talk about energy and here is the progress of reaction. What I have written here? For exothermic, enthalpy of reactant is more than enthalpy of product. So, if it is the enthalpy of reactant, this will be the enthalpy of reactant, then what will be the enthalpy of product? Here we write the product. And this will be the enthalpy of product. So, it is justified. Enthalpy of reactant is more than enthalpy of product. So, this is for exothermic reaction. Now, similarly for endothermic reaction, if we write energy on this side and progress of reaction on this side, progress of reaction in this side, what will happen? In this case, the enthalpy of reactant is less than enthalpy of product. Now, this is reactant and this is product, and this is the enthalpy of product. And this will be the enthalpy of product. And this will be the enthalpy of reactant here. HR, and this will be HP. So, this is the enthalpy change during exothermic and endothermic reaction. Now, if we consider this concept in this equation, if we talk about HP is less than HR, then if this value is greater, this means delta H will be negative. But in case of endothermic reaction, and negative means heat is released out. Enthalpy change whenever the reactant is less. Now similarly in this equation, delta H is equals to HP minus HR. This HR is less and this is more, then delta H is positive. So this means heat is absorbed. So this is all about endothermic and exothermic reactions. Now, thermochemical equation is when a balanced chemical equation is written along with the quantities of different reactants and products. Along with these reactants and products, the amount of heat evolved or absorbed is also indicated. Means whenever we have write balanced chemical equation, then reactants and products are indicated. Along with that, the amount of heat evolved or absorbed also indicated, then that reaction is called thermochemical equation. For example, in this reaction, these are reactants and these are products. Along with this balanced reactants and products, there is the amount of heat which is evolved. So this means this can be indicated by this way, or it may also written as delta H minus 285.5 kilojoule. Now you understand why I put negative sign here, because it is an exothermic reaction. This heat is released basically. It can be written in this form as well as in this form. So these type of equations are called thermochemical equations. Now come to heat of reaction. It is the amount of heat evolved or absorbed. Evolved means release. This evolved means release. Amount of heat evolved or absorbed when all the reactants gets completely reacted. When all the reactants have completely reacted. जो सारे reactants completely react हो जाते उस time पे जो energy, जो amount of heat release या absorb होंदी है, that is known as heat of reaction. Now let us consider an example. 2A plus 3B and it will form 4C. We know that enthalpy change is equals to delta H is equals to HP minus HR. Now in this case, if there is any stoichiometry present, these are stoichiometry which are used to balance the reaction, then these must be included in this case. Now these are products, so we will write 4HC. 4 is stoichiometry, HC is the enthalpy of this C product, minus, after this minus, now come to reactant, 2 enthalpy of A reactant, now there will be plus sign, 3 enthalpy of B. Now we can also write it as 4HC minus, when we open the bracket what we get, 4HA plus minus minus 3HB. This will be your enthalpy change during this reaction. So this is the heat of reaction, which is the amount of heat evolved or absorbed when the reactant is completely reacted. Now, there are certain factors on which the heat of reaction depends. First is quantity of reactants involved. In this reaction, we will see here 1 mole of hydrogen is used, half mole of oxygen and 1 mole of water is used. And this much amount of heat is released. And if we double the amount of H2, what will happen? This entire equation gets multiplied with 2. Along with this reactants and product stoichiometry, this heat change will also gets double. So what will be your reaction? 2H2 plus O2, it will form 2H2O. Then what will be your this enthalpy change? It will become 16, 11, 16, 17, 571.6 kilojoule per mole. So we can say that if we double the amount of reactants, then the heat of reaction will also get doubled. Now come to second point, physical state of reactants and products. See these two reactions. In this, hydrogen reacts with oxygen and form water. Similarly, in this reaction, hydrogen reacts with oxygen and form water. See the difference here. Here water is in gaseous state and here water is in liquid state. When water formed is in gaseous state, then the enthalpy change is minus 285.8 kilojoule per mole. But when it is in liquid state, then its enthalpy change is minus 241.8. There is the difference. So this means whenever the physical state of reactants and product will be changed, then the heat of reaction will also get changed. Third point, allotropic modifications. Here, carbon reacts with oxygen and form carbon dioxide. Similarly in this case, but the difference is in the first reaction we are using carbon in diamond form and here carbon is in graphite form. What's the difference? We are using different allotropes of carbon. Whenever we use different allotropes of carbon, there is a difference in enthalpy change. So, whenever we do allotropic modification, then the heat of reaction will also get changed. Next is concentration of solution. If we change the concentration of reactants or products, then the heat of reaction will also get changed. Next factor is temperature. The heat of reaction also depends on the temperature on which that reaction takes place by this equation. Now if we modify this equation, dH is equals to, by cross multiplication, it will become Cp dt. We can also write it as Cp, we can write it as this dt as T2 minus T1. This is the temperature change. So by this equation we can say the heat of reaction also depends on temperature and this equation is called Kirchhoff's equation. Now come to next factor, condition at constant pressure and constant volume. Now this is the enthalpy change at constant pressure and this is enthalpy change at constant volume. So by this equation we can say that heat of reaction may also get changed on keeping the pressure constant or on keeping the volume constant. So these are the factors on which heat of reaction depends. Now we will discuss different types of enthalpies of reaction. Now first type of enthalpy is enthalpy of combustion. Now what is combustion? Combustion is burning of any substance in the presence of air, specifically oxygen. Like this carbon is burnt in oxygen in the presence of oxygen and it will form carbon dioxide. If the supply of oxygen is limited, then it will form carbon monoxide. So it is the heat change when 1 mole of a substance is completely burnt in presence of oxygen or you can say in presence of air. So this is the heat change when 1 mole of the substance is completely burned in the presence of oxygen or air, that enthalpy change is called enthalpy of combustion. Now, related to this concept, there is a calorific value. This is related. This is basically the amount of heat released when 1 gram of a substance is burnt in air. Here we talk about 1 mole of a substance, and this is a heat change. And in this case we talk about heat is released when 1 gram of a substance is burnt in air. Now understand with this example. Here are two examples. In these examples, when we burn this substance, this much amount of heat is released. Now, on the basis of calorific value, we can also tell which fuel is better fuel. So, if the calorific value of any fuel is more, then from that fuel, much more heat is released. More heat is released, then that fuel will be a better fuel. Now, consider from here, if we burn methane and it will release this much amount of heat, in 1 mole it is 16 gram. This is its molecular mass. Now, if we want to calculate how much amount of heat is released when 1 gram of methane is burned, simply we can divide this amount of heat with its molecular mass. On dividing, we will get 55.64 kilojoule. Now, similarly, next example, here hydrogen will be burned in the presence of oxygen. Here this hydrogen is 1 mole. 1 mole means 2 gram, but we are talking about 1 gram. So, to calculate 1 gram, this heat change will get divided by 285.29 divided by 2. It will become 142.645. This will become this much amount of heat. Now you tell me, out of these two, whose calorific value is more? The calorific value of hydrogen is more. So if the calorific value of this hydrogen is more, then more heat is released in this case. So it is a better fuel than methane. So with the help of calorific value, we can also determine which fuel is better and which fuel is not better. Next is enthalpy of formation. Enthalpy of formation is, it is amount of heat released or absorbed when 1 mole of substance is formed from its constituent elements. Mark it important. When 1 mole of a new substance is formed from its constituent elements. Means carbon dioxide is formed from two elements, carbon and oxygen. If this carbon dioxide is formed from carbon and oxygen only, then it is formed from its constituent elements. But if it is formed from some other source, for example, if we say CaCO3, if we heat it, then it will form CaO and CO2. Here carbon dioxide is also formed, but here these are not the constituent elements from which the carbon dioxide is formed. So mark it important. Whenever the 1 mole of a substance is formed from its constituent elements, then that amount of heat absorbed or released is called enthalpy of formation. Now in this case, this delta H is called enthalpy of formation. Now see next example. Is these two are the constituent elements of this calcium carbonate? No. Calcium oxide is basically formed from calcium and oxygen, and it is formed from oxygen, carbon and oxygen. So these are basically compounds or molecules. These are not constant elements. So this delta H is not calculated directly. This delta H is not the enthalpy of formation. So for such cases, we will not calculate the enthalpy of formation directly. For this, we have to use one law that is known as Hess law, which we will discuss after the discussion of different types of enthalpies. So enthalpy of formation of such reactions can be calculated by using Hess law. Now, For some elements like H2, Cl2, diatomic atoms, their enthalpy of formation is 0. Now if we talk about enthalpy of formation of reaction, then it will be equals to summation of change in enthalpy of reactants, products minus change in summation of change in enthalpy of reactants. For this we will consider one example. AA plus, this is the generalized reaction. It will form CC plus DD. Now the enthalpy change for the reaction. First we have to write the products. This stoichiometry will remain with it. This is stoichiometry. Delta H F for C plus D delta H F for D. These are products minus A delta H F for A plus D delta H F for D. So this is the enthalpy change of a reaction for certain reaction if we want to calculate. Now come to next enthalpy of a neutralization. Neutralization means when acid is mixed with the same amount of base, then it will become neutral solution. That reaction is called neutralization reaction. So heat is evolved. In this case basically heat is evolved when 1 gram equivalent of acid is neutralized by a base. When 1 gram equivalent, here we talk about gram equivalent, not the mole. So understand the term gram equivalents. So how we calculate the gram equivalents? This is basically depend upon acidity and basicity. So gram equivalents of acid is neutralized by a base. For example, NaOH is a strong base and HCl is a strong acid. When these both react together, it will form a salt, and this is the enthalpy of neutralization. Now if we consider a strong base along with a weak acid, or a weak acid with a strong base, or a weak acid with a weak base, then the enthalpy of neutralization will always be less than this enthalpy. If we consider weak base with strong acid, weak acid with strong base, or weak acid weak base concept, then the enthalpy of neutralization is always less than this enthalpy of neutralization. Next one is enthalpy of solution. This is amount of heat change. Heat change means heat absorbed or evolved. Whenever I have written heat change, this means it involves absorbed as well as evolved. When 1 mole of a substance is dissolved in desired amount of solvent, what will happen? We dissolve KCl, which is already in solid state. When we dissolve this KCl in water, it will convert it into solution form, which is aqueous. At that time, the amount of heat absorbed or released, that is called enthalpy of solution. Next is enthalpy of atomization. Atomization means breakage of molecules into atomic form. That is called enthalpy of atomization, the amount of heat absorbed. In this case, basically, whenever bond is break, then amount of heat is absorbed. When 1 mole of a substance dissociates into gaseous atoms, this H2 is a molecular form, changes into its atomic form, the enthalpy change is enthalpy of atomization. This is equals to bond dissociation energy. Basically, the bonds present between hydrogen, it will form H2 molecule. To convert it into hydrogen atoms, this bond will get break. This bond will get break. To break this bond, the amount of enthalpy required, that is enthalpy of atomization. We call it bond dissociation energy also. Next is enthalpy of ionization. Ionization means to convert any solid liquid substance into ionic forms. When a covalent compounds are those compounds on which no positive or negative charge present. On dissolution in water, when we dissolve any covalent compound in water, it will split into ions in the solution. See, here this HCl is covalent compound. When we dissolve it in water, this will split into H positive aqueous and Cl negative aqueous. These are the ionic forms. So this HCl will get ionized, and this enthalpy change is called enthalpy of ionization. Next one is enthalpy of hydration. Hydration means addition of water. When 1 mole of anhydrous means without water, anhydrous salt combines with required number of moles of water so as to change into hydrated salt, the salt containing water. So, enthalpy of hydration is basically the enthalpy change when 1 mole of a substance combines with, substance means anhydrous salt. It will combine with water and it will form hydrated salt. So, copper sulfate, when it combines with 5 water molecules and it will form hydrated salt. And the heat change during this reaction is called enthalpy of hydration. Next is enthalpy of hydrogenation. Hydrogenation is, every enthalpy's meaning is in its name. Understand the name first. Enthalpy of hydrogenation. Hydrogenation is addition of hydrogen. So, when 1 mole of a unsaturated compounds are those which contains double or triple bond. As in this compound, unsaturated organic compound which are normally made up of carbon and hydrogen only. Organic compound in completely hydrogenated. When the enthalpy change, whenever any unsaturated organic compound reacts with hydrogen and it will completely hydrogenated, means ਉਹਦੇ ਹੋਰ hydrogen add ਕੀਤਾ ही नहीं जा सकता. On adding 2 hydrogens, it will become this. If we talk about this, now see, is there any further hydrogen will be added to this compound or not? See clearly. Initially we have this compound. On adding 2 hydrogens, it will become, is there any further more hydrogen will be added to this compound? No, because we already know that the valency of carbon is 4. It is already tetravalent. So, when 1 mole of unsaturated organic compound is completely hydrogenated, at that time the change in enthalpy is called enthalpy of hydrogenation. Next is enthalpy of allotropic transformation. Allotropic means any element exists in 2 or more forms. For example, sulfur exists in 2 forms, orthorhombic, monoclinic, 2 types of sulfur, rhombic and monoclinic. And similarly, phosphorus, red, white phosphorus. And similarly, carbon's allotropic forms are graphite and diamond. When we convert, when 1 mole of one form of an allotropic modification changes into another, when one allotropic form changes to another, the enthalpy change during this reaction is called enthalpy of allotropic transformation. In the continuity, enthalpy of formation of ions. Formation of ions means ionic species will be formed. But initially we have studied that when covalent compound is dissolved in aqueous solution, it will dissociate into ionic form. Here we talk about when an ionic solid dissociates to produce free ions in water. Here we talk about ionic solid. When ionic solid will dissociate into free ions, when we dissolve it in water, the enthalpy change during this reaction is called enthalpy of formation of ions. Consider this example. In this example, what will happen? This hydrogen, half mole of hydrogen combined with half molecule of Cl2, it will form HCl. This HCl will dissolve in aqueous solution and it will dissociate into ions, which is H positive and Cl negative. Now, if we want to calculate the enthalpy of formation of these ions, how we will calculate? This enthalpy is basically the enthalpy of reaction, which is the dissociation of this molecule, and this is the enthalpy of formation of this molecule. Now, if we want to calculate the enthalpy of formation of this Cl negative ion, what will we do? Enthalpy of reaction, which is equals to summation of enthalpy of formation of products minus summation of enthalpy of change of enthalpy of formation of reactants. Now see, what is the product here? Delta HF of Cl negative minus, what is the reactant? HCl. Delta HF of which? HCl. This is delta change in enthalpy of reaction. Change in enthalpy of reaction is minus 75.2 and this we want to calculate, and this is minus 92.8. Sign should be taken carefully. Now if we keep it here, delta F H naught Cl negative, this will come this side. Here it is negative, negative, positive. When we brought this in this side, then it will become again negative. Minus 75.2 minus 92.8. On solving, what you will get? Minus 168 kilojoule per mole. This will be the enthalpy of formation of this Cl negative ion. So this is the way to calculate the enthalpy of formation of ions. Now the last type of enthalpy change is enthalpy of phase transitions. Phase transition means when the phase of any reaction will change. For example, anything changes from solid to liquid, liquid to gas, or from gas to liquid, liquid to solid. This means this is a phase transition. So we consider first enthalpy of fusion. Fusion means when the solid changes to liquid. So the enthalpy change when 1 mole of a solid changes to liquid at its melting point. So this is called enthalpy of fusion. Now see, water is in solid state, means this is an ice. When ice changes to water in liquid form, then the change in enthalpy is called enthalpy of fusion, which is plus 6.0 kilojoule per mole. Now, if we take the reverse of it, means the liquid will changes to solid, means the liquid water will changes into ice. Now then we call it enthalpy of freezing, means when we keep water in the refrigerator, it will freeze into ice. That is called enthalpy of freezing. We also call it enthalpy of solidification, because liquid will be changes into solid form. So we call it as enthalpy of solidification also. So what will it become? It will become negative because we reverse the reaction. If we reverse the reaction, this will also get reversed. Now come to enthalpy of vaporization. Vaporization means when the liquid will changes to vapor. When we boil the liquid water in a container, it will convert it into vapors at its boiling point. So the enthalpy change when liquid changes into vapor at its boiling point. This liquid will changes into gaseous form, and this is called enthalpy of vaporization. Now similarly, if we reverse, vapors will changes to liquid, then the enthalpy change will get reversed, which is minus 40.7, and then it is called enthalpy of condensation. Enthalpy of condensation. Now next is enthalpy of sublimation. Sublimation is the transformation from solid to gas directly. So when solid changes directly into vapor at its given temperature, at any certain temperature which is below its melting point, which is lesser than its melting point. So consider an example. Iodine is in solid state which is changes to gaseous form, and this is the enthalpy of sublimation. Sublimation is basically what? Sublimation is solid is directly changes to gas. For sublimation there are two steps: solid changes to liquid and then liquid changes to gas. So if the enthalpy of sublimation is not directly given, we can calculate by adding enthalpy of fusion plus enthalpy of vaporization. Solid changes to liquid is enthalpy of fusion and liquid to gas is enthalpy of vaporization. So we can calculate enthalpy of sublimation by adding these two enthalpy change. This is all about the different types of enthalpies. That's all for today. Thank you and have a nice day.